Start recording. There we go. All right. So last week we didn't end up with a recording. So this week we should. The screensaver has been set to 60 minutes, not 1 minute now. So we shouldn't be having any of the problems of losing the desktop sharing anymore. It's being recorded. We should be able to have an actual good recording. One announcement is if anybody wants to keep having the lecture closed captioned for whatever reason, contact me privately, and I will ensure that we continue to do that. Otherwise, I'm going to opt out of and not have the closed captioning being done because somebody somewhere is paying this person who's listening to me talk and do all the typing. I'd rather have the money go to somebody, some other class that actually needs it. So if nobody here needs it, I will dismiss them. But if there anybody wants to have that closed caption text, let me know privately, and I will continue it going. So somebody's actually listening over the internet typing. Wow. Yes. So I'm going to start with going through some Java language basics. Then we'll get into using the Eclipse editor, getting it set up for your first use. And then we're going to go through a number of code demonstrations after that. I should start with questions from last week, questions from the homework. Yes, David? Okay. The @C attribute, where can it go? Well, it depends. That's where it's going to be. What do you want to reference? So where should the @C annotation or Java doc tag? We're going to talk about annotations here later, and they look the same as Java doc tags. Where should the @C go? It can go in the method documentation or the class level documentation, depending on what you're referring to. So it's not a should, it's more along the lines of what are you attempting to document, and where is it then more appropriate. If you are trying to reference something that's being used inside of a method, then I would recommend using the @C in that method's Java doc block. Whereas if it's something generic to the entire data type and to the entire class, then I would put it in the class documentation. So it depends on how it's being used. Yes?
There was somebody who tried to resubmit, and you told them just go ahead and resubmit.
Uh-huh.
And I tried that, I couldn't do it, so I emailed the second submission to you.
Oh, Moodle was not accepting. Okay, because I received a number of messages that people had updated. So if it gives you any problems, yes, definitely come back and use email for backup.
I think one part of that is you can like submit a draft, and then there's a button that says submit for final. Here's final submission, and I think once you do that, you can. So maybe
I will make sure that Moodle is set up so you can always resubmit. So I started using Moodle last spring for homework submissions, so I'm still kind of new on it. And when I copied things from the spring semester to the fall, things got weirded out. So the due date is midnight Thursday night. Yeah. So you've got until midnight Thursday night to work on it. Okay, let's go and take a look real fast. We'll jump out to a command line. So at the moment, I have my hello date example. I've got my .java file in here. I've got the .class, all inside of a single directory. So from that directory, haven't navigated to the right directory. I want to go to that containing folder. So here are my files that I want to have zipped up. I'm going to go up level to that containing folder, zip the entire folder. Okay? So I've already got that done from last week. Name it. Project A, last name, first name. And then you're going to upload it through the Moodle system. So the easiest thing to do is to follow the links through the project pages. So from the main page, I'm going into the Project A page at the bottom. The link over here is to the Moodle page. I have to log into Moodle. And then from here, because I'm listed as the instructor, I don't actually see the submission form. But here, there'll be a selection for you to pick the file and upload the file from that point. Oh, the new interfaces. Okay. Yeah, I haven't played with. I haven't seen that. I saw the drag files here for the forum posts, but yeah. So once you get into Moodle, then you'll have the file upload tools. Okay. Any more questions out of last week's work getting things up? Did anybody not get their environment running? Okay, we figured out what was up with the virtual VM thing, but the command line environment, yeah, because we start with Eclipse tonight. So, okay, so let's go back to going through the language basics then. So one of the guys who has done a lot of work, written a lot of books about object-oriented programming is Alan Kay, and he was somebody who was involved with Java and C++ work early on. And so he developed certain rules about object-oriented programming and what constitutes pure object-oriented programming. First rule is that everything's an object. In some other languages, they're object accessible kinds of things. You're using objects to do programming, but it's not object-oriented programming. An example is Visual Basic, particularly the pre-VB.NET versions, like I think it was VB6 and that kinds of things. You're using objects, but you're not actually using all the principles of object-oriented programming to write your applications. Programs are collections of objects that pass messages back and forth to each other. Each object has its own memory and is composed of other objects. I swear this slide is probably 6 years old. I just noticed that spelling typo. Every object has a unique type. So when we create a class, we're not creating an object at that point in time. We're creating a data type. And so each object that's being used in the system has a distinct and defined type. And then all objects of the same type can be worked on and used exactly the same. They all have the same interface. So Java attempts to achieve this pure object-oriented language and meets these rules. However, you can do non-object-oriented programming in Java by writing interfaces in Java that connect to native code. So if you, for some reason, have a device driver that's set up to run in a Windows environment and you've got a piece of C code, you can interface to that piece of C code to talk to that driver from your Java application, but then you no longer have a pure object-oriented application. It is also no longer portable because it is now tied to whatever platform your C code has been compiled for. So a bit of a diagram about the structure of classes and objects. We've got a class. It has functions on it. We refer to them as methods in object-oriented programming. If you've done C programming, you call them functions. In other languages, we call them functions. They're called methods. It's just a different name, different terminology. Within our class, we're going to define data members, actual fields that will hold the data that we're interested in, strings and integers and things, perhaps other complex objects, most likely other complex objects as well. Then we'll have bunches of functions and methods that actually mutate the data. They could set fields within the objects after they've been instantiated, or we have methods that access those fields and bring data out. So we can create from our class definition objects by instantiating whatever the name of that data type is, assigning it to an object reference of the same type as what we're instantiating. Then we can do things with it. We can pass that as a parameter into a function, into a method. See, like I said, function method, it's interchangeable. I use both of them. And on my object that I've got, I can call methods that have been defined within my class definition. I can call a method called setValue and pass in a parameter that will actually set a field inside the instantiated object. Something to remember is that all objects are going to have an interface. Our objects have their type name, and then they have the interface. And the interface is going to be the methods that you can call on an object of the given type. So all objects of type light are all going to have these four methods. They're all going to have an on method, an off method, a brighten, a dim method. And this is the interface. This is what you present to the client code. The client code is any application or piece of code that's going to call this class. So our interface is defined by what's being presented to everybody else. The stuff that's inside, that's private, just however it's been implemented, we don't have to tell everybody else about that. That's internal kinds of things. We don't have to publish that information, so that's not part of the interface. At some point, we're going to want to start reusing the implementations. The common methods, for a car, data type would be start and drive. And our internal implementation is it's going to have an engine. It's going to have a number of wheels. It's going to have a number of doors. But the number of wheels and the number of doors doesn't have anything to do with somebody being able to say, okay, for that object, tell it to start driving. It doesn't matter about the implementation. It just matters that I can call the drive method on that object. When you've got an individual object that's a car, that's pretty specific, as opposed to having more generic data types. This is our classic shapes example for object-oriented programming. We define a base class called shape and define the interface of those two, of that data type to have a draw and an erase method. So that's the interface. So we can say every object that is a shape will have a draw and erase method on it. So our circle is going to support draw and erase. Our square object is going to be supporting draw and erase, and so is our line object. The benefit of having this hierarchy of classes and having a base class that defines the interface allows us to have data structures and or methods that we can pass any of these objects of that common type to. So I can define a method that does something that takes a shape, but then I can instantiate a circle, a triangle, a line. Since all of these classes implement the shape interface, these objects can be passed to that method. That's the polymorphism at work for us. The thing to remember about this diagram and a circle class inheriting from a shape class, circle is a shape. Whereas in our previous diagram, the car has an engine. So we've got is-a relationships and has-a relationships. When we're talking about the is-a relationship, that's when we're getting into inheritance and common interface implementation. So our object-oriented programs are going to be have multiple objects involved. When we start a simple hello world program, we've got one object being created at least within that application. Our our static main method gets called, but then we're doing outputting of strings, and so we're creating strings, and that's an object inside of our program. Multiple objects within the system are going to communicate with each other by passing messages. The object-oriented programming term is not calling a method, but you're passing a message, is the formal term for it. We normally just say, I'm calling such and such a method on that object. Often you learn more and more about the problem you're working on as you go. You have to be willing to go and look at the way you've designed the program already, and with that new information you've learned, you have to be ready to tear parts of it apart, add new layers into the program, and start actually dealing with those new pieces of information that you've come up with. The nice thing about object-oriented programming is that we deal with a lot of layers. We wrap data with other data. We have objects and classes defined within other ones. And because we wrap things a lot and we have multiple layers, it makes it easy to pull out an entire layer and replace it, because the layer is just talking to objects using their interfaces. It's not caring about the internal implementations of things. It makes it easier for us to replace things when we've learned something new, or the business people have come up with a brand new requirement for the application that you hadn't considered, at which point it's very disruptive and you start pulling things apart and rebuilding them. In Java, we're going to manipulate objects a lot. We're going to always be manipulating them through their object references. In Java, we are going to create references as a declaration in either at the class level or inside of our methods, and that's going to be using a data type and then a variable identifier. Normally when we create an object, we're going to use the new method. We're going to tell it what class we want to instantiate. It's going to have parentheses, and it's going to have 0 or more arguments that are being passed into the constructor of that data type to actually instantiate the object. And then we always assign it to an object reference. Now, strings are special. We can do static initialization of strings by doing the double quotes, whatever we want inside there. And the compiler knows, because strings are the single most common object you're going to work with in any programming environment. The Java designer said, hey, since it's going to be so common, why do we want to have everybody type new string, open parentheses all the time? Just make it easy and have this shortcut. So that's built into the system for you as a shortcut as a developer.
Would you ever have a string next to a string where a string, the first string and the second string don't match up? It doesn't seem like they'll always be the same, right?
You mean the values?
Of one type and assign it to a variable of that exact same.
You're asking a question that we have until first week to deal with when I talk about initialization. And then actually later on we're going to specially talk about strings. We're going to spend an entire lecture just talking about strings and how they're different and special than the regular objects. So the initialization, when we get to with an initialization next week, we'll be talking about testing for equality. Alex? Sorry? Alan. Alan was asking about that earlier as well. Testing for equality is something we need to talk about initialization first.
Because you do strings both ways, the more correct way and the shortcut way is generally what's found in the
Nobody ever writes this. Nobody ever says new string. But again, when we get to the week covering strings, we're going to talk about efficiencies and different ways to approach what is the more efficient way of building strings, because we don't use a string class to build strings when we're trying to be efficient. Now, Java also has primitives. We've talked about objects. Objects are defined by a class definition, and that's a data type, and there's a .class file when you compile the source code, when you create it, and it creates objects when you instantiate them. But Java also has primitives. Primitives are not objects, they are strictly values. All the typical data types that you've come to become familiar with in C and C++ programming, booleans, characters, bytes, shorts, ints, longs, floats, doubles, and I know I'm missing a couple. They are all there. Now the question comes up is, if we're trying to do a pure object-oriented programming language, why do we have primitives? And it comes down to, back in the early 90s, it was about efficiencies. And the designers of the language needed to have primitives so that they would be able to have a decently responsive system when they built applications with Java. Following on from Java and trying to make pure object-oriented systems, the .NET system, on the other hand, is purely object-oriented. They don't have primitives. When you create an integer in a .NET language, you are still creating an object, at which point you can still call methods on that. They did away with the concept of primitives in the .NET environment. Now, because we need to work with objects a lot, they created object wrappers for these primitives. So we represent a primitive integer with int, but then there's the data class, the class type integer with a capital I, and that integer data type wraps an integer value inside of it, a primitive integer value inside of it, but then gives you a bunch of methods that you can use to work with it. Once you've created these wrapper objects, when you say new integer and give it the number 4 as a parameter going in, that's a read-only object. That value is now locked in for that object, and you cannot modify it. You can call methods on that and get the value out, but you can't actually change the internal value on these wrapper objects. If you want to, you actually have to create brand new objects of those wrappers, a brand new integer object if you wanted to do math like with it.
You have to reassign the value, or like
you have to instantiate a new object, and you could reassign it to the object reference. So a couple examples of working with wrappers. I've got my char primitive variable, and this is a variable. It's not an object reference because it is of the data type char. I assign a character. We use single quotes for individual characters. We use double quotes for strings in Java. Some languages like PHP let you intermix. You know, you can use double quoted strings or single quoted strings. In Java, all strings have double quotes around them. I can instantiate a wrapper class passing in the character variable, but what we normally see is we'd instantiate that with the static literal there as a parameter going in. We've got arrays in Java. They are first-class objects. When you create an array, it is an object that's being created, and there are array methods and fields that you can access on any created array.
what I've been wondering about is, it seems like you're giving two names to that character in the net.
This is my name, my identifier. This is the value.
Right. Oh, whatever.
It's the letter X, that like on the keyboard. But it's not a different name though. Okay. One of the classic things you could do in C and C++ is declare an array, say, hey, this array's got 10 elements in it. You start looping over it, and you've goofed up your logic on your for loop, and when you get to you incremented your pointer and trying to accessing the 11th element of the array, C is perfectly happy to give you a value for it. In Java, you're going to get a runtime error. It's going to say, you went past the end of the array, stop doing that, go fix your code. All right? Java will tell you when you have gone beyond the end of the array. An out-of-bounds exception is very common to run into. You should never have that happen at runtime because that means you've got a mistake in your code. And we'll be going over these in week 5. Chapter 17 actually goes in depth to all the nitty-gritty about arrays. And our Java supports multi-dimensional arrays, so as many dimensions as you want to deal with, it'll support. We have scopes in Java. We've seen the curly braces define the beginning and the end of a method so far in the code last week. But you can arbitrarily throw curly braces in the middle of your code just to say, this is a block of code that I want to have some boundaries between what's inside this block and what's outside of the block. And so we can redefine values and have them at different scopes. So inside the inner block there, we can't redefine the variable x, the integer variable x, but it's accessible to us. But if I define something inside the inner block, I cannot access it in the outer block. So the outer block doesn't have visibility into the inner block, and it's a way to do some interesting code. Generally, we don't see this happen a lot, the arbitrary inner block like that, but anytime you write a for loop or a while loop, that's what you're getting. You're getting this inner block inside the outer block, and you need to be careful about how things are referenced across those blocks. Everything in Java is passed by value, but that's method calls. Okay. No. You would have to have something defined outside of the inner block. You could assign a new value to that reference and then access it later on outside of the inner block. We do that all the time. For example, building strings. We define an object reference that points to a string, and then inside the loop we start appending to that string, and then we use it when we exit the loop. So we can do that.
Well, what it's like, for instance, after that certain block of code is run, will whatever memory is being used for Q be discarded after that particular code block is run by the programmer?
When there are no more references to this identifier, then Java will clean it up, so long as there are no more references to it. Okay.
Like we use this like memory efficiency in your code.
It could be, yeah. Getting into efficient code gets into individual specific problems, though. So each problem for how do I make this more efficient, we have to address each one of those individually. But it could be used for that, yes.
So X is read only. So read it, we can't write to it inside that block?
No, we can write to it, but we can't redeclare it.
Oh. Okay.
We can't eclipse, eclipse the previous definition of it.
You can't redeclare it within that block, you redeclare it outside that block, and you go to the next block, and the next block.
Down here?
That's not redeclaring, that's just changing the value.
But making an assignment. But when I have the data type out front, that's a declaration.
Yeah, you know, what I'm saying, that line you just pointed to, uncommented, and moving down below the X++. The line in that line that you just pointed to, uncommented out.
And put it down here. Yeah, it will throw an error because I defined it and I'm in the same block and it's still visible. Okay. First example for that is that there is a whole library of code that's available to us that only takes objects. The capital O object is a parameter, and you can't pass primitives into it. So we take a primitive value, wrap it in, say, a primitive integer, wrap it in the integer object, and then we can pass it into a method that requires an object, capital O object, as a parameter. Right.
For the curly braces and kind of fencing off that declaration, how does that affect aliasing? Where you got two different, you got X and you got Q, they're both pointing to the same reference. How does the curly braces affect that at all? Or is that like a
So, in this case, we've got two object references defined and one object created. So I've instantiated my object. I can assign it to O. And then inside the inner block there, I can assign O to P. Now that's not copying the object. That's only assigning the memory location at which this object that was created points to. So now O and P will point to the same memory location where the instantiated object lives. But P is no longer accessible when we get outside of that block. We can have multiple object references pointing to the same instantiated object. It's just like pointers in C++. I said we don't have pointers, but we have object references, which is almost the same thing. We can't do pointer math. You can only reassign it. It simplifies it compared to C and C++. Null pointer exception. That's when you try and access an object that doesn't point to you try and access an object reference that doesn't actually point to an instantiated object. So, sorry again? No, that would say down here, if you tried to access P, it would say, I don't know about P. I have no idea about it. But if I never did that assignment, and I had a P, and I tried to do the system out print line P here, it'll say, hey, P is defined, but it doesn't point to anything, and that's a null pointer exception. Again, that's probably going to be one of the most common exceptions, error messages that you get. That indicates, again, that you didn't instantiate and create the data that you expected to. Yes?
So, actually, you're not seeing a value assigned to it. So it's just whatever happens to be.
Whatever is inside. I mean, the object is the value in this case, right? And what the actual internal value, the object reference that somewhere in memory kind of pointing, we are not supposed to know what that is. We are supposed to be removed from that as Java programmers. Because if we knew about it, we'd start manipulating it, and that would get into messing up all kinds of memory allocation stuff and garbage collection. They designed the language, so we are not supposed to know. When we think about it, you'll realize at some point it's actually just an integer pointing to some memory location kind of thing. But we don't need to know it. We just need to remember it's either going to point to an instantiated object, or it's going to have a value of null that will cause a null pointer exception.
So right now it's just a simple reference, right?
It's just a reference, yeah. So last week we saw the Hello World program. We saw using a class, but really what the class keyword is for is defining new data types. So that's one of the things that you'll be doing a lot of in this class, in this course, is using the class keyword, giving it a name, creating fields inside that class, and then creating methods that will act upon those fields. Data member and field, interchangeable terms for those. Thing to remember, every time you instantiate a new object of a given type, they each get their own copy. Each object gets its own copy of the fields. But those method definitions are the shared component that the system goes and only keeps in the class files. So when you instantiate an object that say got half a dozen integers in it, that's all the space in memory you're taking up is for those half a dozen integers. You're not taking up any space in memory for the code for the implementation of the methods in the class definition. I've declared these three fields inside the new type class. They do not have any assigned values to them. I just have my data type. I have a variable name. Call it a variable name when it's a primitive. Call it an object reference when it's an object. I don't have an equals and a value after it. So these are uninitialized variables. Java does not like the idea of an uninitialized variable. So if you write this, Java will give these all a value. It assigns 0 to all of them. So the integer 0, float 0, Boolean becomes false. False is 0 in Java. Characters get the Unicode 0. So whatever that first character is in the Unicode character set, it gets assigned to characters. If it's an object reference you've got declared there, it's going to also get a 0, which is otherwise known as null when we're dealing with object references. And we're going to be dealing again with more initialization stuff next week.
Are all characters in Unicode?
Yes. It's same with the strings. You can actually go either way. You can use escape codes to indicate I'm going to use Unicode to specify a character, or I'm going to use ASCII to specify a character. You can go either way.
So is that just like an extra that's a skill since Java
It automatically initializes it for you. But the problem with letting it assign values is that you may have expected a value to be assigned later on, and Eclipse will actually point it out to you, say, hey, you declared something and didn't actually initialize it. Are you really sure you want to do that? The thing is with Java, you will have a value. It's not an unknown. You will have a value, but for the sense of your program, does it make sense? And Eclipse will warn you. It's a warning situation in the Java environment. Mm-hmm.
In Java, Boolean is back on Boolean. It's not just Boolean anymore.
Right. It's Boolean. Mm-hmm. Yes. We'll work with Eclipse tonight to show you how to type less, okay? So yeah, I'm going to use Eclipse to actually write pages of code for me tonight. So here we go. We can add functionality. We have our classes we can add behaviors to through methods. Again, we traditionally call them functions in C and C++. We would call them methods in Java. Unlike C and C++, you can only define methods inside of a class definition. You used to be in C and C++, you could define methods outside of the class definitions and have these methods that were then essentially utility methods you could use anywhere kind of thing. You can't do that in Java. We've got similar techniques to achieve the same thing, but you have to put all the methods inside of a class definition. We use the dot operator to invoke methods. So I've got an object reference. I use the dot operator, and then I can call the F method on a object here. And I can see that the F method will return some integer value there. We've got arguments and parameters. When you call a method in the client code, what's being passed in is the argument. When you define a new method, that list of 1 or 0 or more items are parameters. So when you make the call, it's an argument. When you make the definition of the method, the parameters inside the parentheses. Right. One of the key things you've got to remember in Java is that when we call a method, it's always going to be passed by value. So if we pass a primitive in and we manipulate that primitive inside of our method, when I exit that method, the value in the calling scope of that primitive will not have changed. But in object references, we're passing an reference to that object. That is being passed by value. We're copying that value into the body of our method. But we now have a pointer, an object reference inside the body of our method that points to a memory location. And the body of our method can manipulate that memory location, that object, call methods on it, mutate with internal values. And then when we exit the method, that object still has those changes. It's the object reference only that is being passed by value, not the object itself.
By object reference,
The pointer. If it makes you feel better to call it a pointer, in Java we refer to it as an object reference. I'll beat that out of you here in the class. When you switch languages, you start to learn you got to do things in different ways. We talk about Java in a different way than we talk about PHP or C++ or C#. Some of the things that you're going to work with in Java are learning the new naming conventions. When I started doing training in .NET and C#, I couldn't stand the way they named things in C# because it made so much sense to me to do Java's way. We have a defined way of naming things. You don't have to follow the conventions, but I'm going to slap your hands on your homework if you don't, being one. And everybody else you work with will be going, what are you doing? Why are you naming this in a strange manner? We have naming conventions so that it's a communications tool in Java. We're going to name classes a certain way. We're going to name objects a certain way. And by following those conventions, you hand the code to anybody else. They're going to know, okay, this is a class and this is an object reference. And there's no confusion because we all follow the same naming conventions. There is a published document on Java language naming conventions, and I think it dates back to 1996 or so. It really hasn't changed much. The two biggest things are that class names are going to start with a capital letter, and then you're going to use upper camel case for the rest of the words. So if you're using multiple words together, you uppercase the first letter of each word as part of that naming. On the other hand, object reference and variables are going to begin, those identifiers will begin with a lowercase character and then have uppercase for the subsequent words inside of it. So if it starts with a capital letter, you know it's an object, a data type, a class. If it starts with a lowercase letter, you know it's a variable or object reference. It's very simple that way. It's probably the one naming convention that is persistent throughout all Java code. All other naming conventions then become whatever your shop that you're working in chooses to have for the naming. Usually I see more rules about you're going to write code in this style and we're going to follow these patterns, and less about what you name your variables. I like very, very descriptive variable names, identifier names. Other people like very simple ones. Just using an I, for an integer somewhere is, the classic problem. What does this represent? Whereas this is actual name out of code I wrote once upon a time for, when you share something on the internet now, you're sending email to somebody to tell them about the cool thing you found. So it was a tell a friend facility in the application, and I named the string for the name of the person sending the email was the idiot annoying people, and the array of email addresses that they were sending the mail to were the poor souls getting the messages. Use descriptive names. I didn't want to write that module. They said I had to write it, so I had fun with it. So. Say again? No. We've got IDEs. It finishes. You type the first 3 letters and it'll finish it for you, kind of thing. So again, getting to the name, some examples here, capital letters for class names. These are actually names out of my previous employer's code. Variables and methods. Methods I didn't mention before. Again, same identifying name as variables and object references. If you're going to define a constant, we use the same as the C structure. We use all caps, and we use underscores to separate the words in the name of the constants. Now, we saw Hello World last week, and so there are a couple of things that were in that program that you just need to know a little bit about now, and we'll get to the more details about that later. First thing we need to know about is the name visibility. And we're going to talk more about that in Chapter 6 later on. But the visibility of the variables of the objects are inside of those curly braces. We had the main method. It took an array of strings as a parameter. That array of strings, we named it args in the code last week, that visibility for that reference is within the curly braces of that method. Using other components, we used the date class in there, and if you're using somebody else's code, you're generally going to have to use that import at the top of the page. We're going to get into actually using packages and defining your own packages, I think about around week 3, week 4 or so. The static keyword is special. You need to know how that works for the way that the main method was actually called in Hello World. The signature of that method was public, static, void, main, and then it took the parameter list. Static has the meaning of we don't have to instantiate the surrounding class in order to call this method. So when I want to create a utility method, I mean the way we had in C and C++, you could define a function outside of a class definition. A static method in Java is a way to define a utility method so that I don't have to go through all the overhead of instantiating an object, that I can just call this method. Generally, with static methods, all of the logic is contained within that method. We don't have to have any class level variables or state data for that data type in order to run the static method. The imports have to do with what you're using inside the method and not whether or not your method is static. Okay. We're going to go actually more in depth to what static can do for you in Chapter 10 of the book. So that will put us probably around week 6 or so when we get into details about that. The key thing is that the main method is static, so the virtual machine can actually call the method. It doesn't instantiate our containing class, it just calls the main method directly. Without the static on there, it won't be able to do it. Oh, I talked through some of this already. Our name visibility, our class library names. One of the things that we need to deal with that is if you write a foo class and you write a foo class that have different implementations, but I need to use both of them in the same program, I need to be able to identify them by different full names. And so that's where we get into our libraries. The class path that's mentioned here, a lot of times before we started using IDEs a lot, or if I'm running a program in a batch mode like from a command line on a Unix system kind of thing, I need to tell the Java environment where to find my libraries of information. And that is encapsulated in a class path variable in the environment. And so the Java virtual machine will look for that class path environment and use that. It's just like the path on your system, semicolon or colon separated list of directories where Java can look for library code. We talked about the imports. The one thing that I commented on last week is we want to try and avoid using an asterisk when we do an import. We want to be explicit about what we're importing. Eclipse, we'll see later on tonight, will handle all the import management for you. If you write this in Eclipse, Eclipse will say, hey, that's not efficient, and it will take that and replace it with exactly what you actually used in your code and have more efficient imports. When I do this, it causes the runtime to import every single class that's in that library. In this case, and that means reading it from the disk, loading it in memory. In this case, I'm only loading the one class definition that I need to know about. It'll change your source code. We talked about this a little bit last week. Comments, block comments straight out of C and C++, / for one-line comments, and then we talked about the Java doc comments, and that was your project day homework. So we've got those in our code. This was the code we ran last week, the hello date, fully documented here with all the Java doc on there as well. So by the naming conventions, we can see because system is capitalized, system is a data type. But I'm calling this out on here on a data type name. That suggests to me that it's going to be some kind of static reference inside it, and I'm accessing that without instantiating a system object itself. Yes? It's easy, but we have to cover I/O in order to actually do it. So that'll be the week before the midterm. Hello? I did not see one when I got here. I've got some boxes kind of thing over here. Okay. And then on this variable, I'm also calling a method on there. Now, I'm assuming that because this is a data type name, and we're calling out on it, we're accessing out. This is actually a field. We rarely do this in code that we write. This out is actually an output stream type of object, and that's been instantiated by the system when it started up, and we're calling the print line method on that output stream. Like you were asking, we can replace the streams with whatever we want. We could redirect the system.out that's currently going to the console. We could redirect it to a file if we wanted to. But we'll cover that the week before the midterm with I/O. All of the flow control that you're used to dealing with in C and C++ are present, and there is no goto. We've got something similar to goto. We've got labels. Okay. You're used to seeing for loops. We have a new version of for loops as of Java 5 called the for each loop. If you've written code in some of the scripting languages, you're probably familiar with for each. But that's not part of the original Java specification. That was new a couple of years ago. Well, Java 5 is going on almost 10 years old now, so it's not a few years ago anymore. Break and continue can be used in place of goto. So I can break out of a loop and exit to the bottom, or I can continue by returning to the top of a loop. And with labels, I can break to a label or continue to a label. Here's an example of that for each. I define a integer array up here. This is a statically defined array. So I've created, I call new on the primitive int, and I put the square brackets on there to say that I'm creating an array, which is an object, so we use the new keyword. Then I use the curly braces to give the initial values of that array. and assign it to the primes variable. The enhanced for loop or for each loop, we start with the data type, a variable that's going to be used inside the loop, and then we put a colon, and then what we want to iterate over. So the array, or later on when we get into data structures, what the data structure we want to iterate over. And then we can do the processing for each one of those elements within that. The book also goes over how to create your own iterable data structures. We probably won't get into that much detail with the data structures, but you can do it. You can create your own that can be iterated over and sent to a for each loop. And I think the data structure stuff is chapter 12. And again, that's probably week 5 or 6. I mentioned we can break to a label. So here's an example from break with the keyword to outer. That'll jump to this point here in the code. No, break is for getting out of a loop. Break and continue are both for getting out of loops. Really what you're doing here is you're bypassing from here, you're jumping out from this for loop outside of that for loop and starting over again. It's useful when you need to bypass multiple loops. Break, without the label, break is going to send control to the next executable line. So if there was no label here, and I called the break, I would skip the system out on this point and go to the one here. I prematurely exit the for loop and go to the next executable line. I think I've got next executable statement. Whereas continue, on the other hand, continue without the labels will restart the loop that we're in. We'll bypass the rest of the code of this block and restart this loop. With the labels, though, it's acting closer to a go-to.
So when you do continue, you wouldn't iterate J? You wouldn't get that J++?
Correct. So we're bypassing it. Because we're going back out to here. But when I go back into the and execute this line, I'm reinitializing J at that point.
So how's the breakouter and the continue starting at different places?
In this case, with the labels, they're acting exactly the same. No. Just with the break and continue is the only place we use labels. That's correct. I'm going to take that one back, except for switch statements, because that's how we exit the block of the case. No, I mean you couldn't break out of a method kind of block kind of thing. You can prematurely return. You can return at any time out of a method. So.
Yeah, like they specifically tell you not to do it, I think it's not a problem. Regardless of the fact that you want to, I think go do it. Yeah, it should be sure to that. Oh, go to it has errors, yeah. Error stuff.
It's going to be rare where you need to do that. And a good design should avoid needing to do it. The one, there's good programming, and then there's efficient and getting your application to perform well. The performance is where I actually see break and continue starting to get used more. is that, hey, I've got a routine that iterates all over this stuff, but if it's a search routine, you want to exit as soon as you find what you're looking for. You don't want to finish iterating over the rest, and for performance purposes, then you'll use that break to get out of there. Right, you can return instead of breaking. And that would be a different way to implement that search routine. But that's one of the places that you're going to want to use it instead of to use a break to get out of that loop. In general, there's probably the few places that you will actually use it. Again, a good design will avoid having to do that kind of thing. Let's see, this was actually pulled out of the application I was working on at my previous employer. So if I've got multiple values for contents, if I've got more than 3 possible values of the get status there, our problem with this code is that it's always going to execute our print line here. Because whatever I get from the value, it's not that, and not that. It's an OR statement. It's always going to be true, no matter what the value is. You can still write bad code in Java. You have to look at the problem, work your way through it. Java is going to help you write object-oriented code more efficiently, do things efficiently. It'll slap your hands when you do something bad. And, you know, if you do something that it'll generate a warning, the uninitialized variables, it'll slap your hands at compile time. In Eclipse, we're going to see little red underlines for errors and little yellow underlines for warnings. It'll tell you up front when there's a problem. At runtime, it'll let you know that whatever you did to perhaps go past the end of an array, you did something wrong in your code, and it'll let you know that. Java is going to give us the tools to build good code, but you can still come up with some goofy logic and write bad code. We actually pulled this out of a running application at one point in time, something that had shipped to customers.
There's only always going to be that if there's only 3 possible sentences, right, for that?
Even if there's more.
Oh, sorry. Yeah.
It's not that, and it's not the, or that. It's no, yeah, because of the ors. If it's difficult to see and understand, then it's bad code, because people can't understand what's going on. So let's get into some demos. So to start with things, let's get Eclipse up and running. Okay, we don't need the slides anymore. So minimize everything. There we go. Did I just lose the recording right? No. Okay. To download Eclipse, go to eclipse.org. There's the Getting Started Now, Download Eclipse link. And you're going to want to download the Eclipse IDE for Java EE developers. The reason I want you to take this version of it, there's about 10 different versions of the Eclipse IDE here. I want you to take this one because it's got all the bells and whistles already added into it, and you're not going to have to add anything. The bare one here is about half the size, but it doesn't have all the plugins already installed. Eclipse uses a plugin architecture, so if you want to add something, add new capabilities, add a testing system to it, you can just add a plugin into the IDE, and then it's registered, ready for you to use on your projects. After the midterm, I'll be showing you how to install the Android Development Tools plugin so you can do Android development using Eclipse. So download the one for EE developers. Pick the appropriate version of the download, the 32-bit or the 64-bit. Again, my recommendation last week was if you have a 64-bit operating system, install a 64-bit Java virtual machine and development tools, and install the 64-bit version of Eclipse.
Is there a quick and dirty, like under the help or about for Eclipse to figure out which version you have? I know I downloaded one.
No. There's no quick and dirty one. What it really is, what these are, just different packages, again, with the plugins. You can look at the list of plugins to figure things out. Now, if you want to say, hey, do I have this particular plugin? Do I have the plugin to do web application development? There is a update facility within Eclipse. You go to that and say, hey, install new software. It goes to the repository, and it says you've already got the web application development stuff installed. You can see if you're looking for a particular module kind of thing. So once you've got it downloaded, I've already gone and extracted it out onto my system. Let's use this one. And it just comes as a zip file. You unzip it and you drop it someplace on your system. Okay? So I unzipped it. I put it on my C drive just because that's where I always put it by my conventions. Inside of this folder, you'll see the Eclipse executable. On Windows, it's the Eclipse.exe. If you're on Mac, it'll have a different launcher for Eclipse there. That's the program that you're going to execute to start the Eclipse system. Now, the download that I pointed to was Eclipse 4.2. So that'll be what I'm using. That's the latest version. It's what I'm going to be using for all of my examples for you. If you have a need to use multiple versions of Eclipse, they're just zip files. There's no real installer that registers anything with your operating system. This is Eclipse 4.2. It's codenamed Juno, but if you need to use 3.6, the Indigo version, you can just have a different folder here next to it, and they'll cooperate and not interfere with each other. Plugins won't get mixed up. Your settings won't get mixed up. They will play nice together with multiple versions of Eclipse. So to start that up, I went and from that Eclipse.exe, I just created a shortcut on my desktop. Let's get these out of the way. Come on. That doesn't look good. It was just thinking hard. This thing has 12 gigs of memory. You know, it's 12 gigs of RAM.
Still a memory issue.
So, okay. When you first start Eclipse, you're going to get this workspace launcher. Now, I wrote a how-to and posted it on the lecture notes. The first time you run Eclipse, you're going to be presented with this message, and I have my Eclipse set up so that every time I start Eclipse, I get this workspace launcher dialog that pops up. The idea of a workspace in Eclipse is that depending on what kind of projects you're working in, you may have to or may want to have different settings for Eclipse. And a workspace is a way for Eclipse to encapsulate those settings. So if I'm going to do my PHP work, I want to have one set of settings for my PHP code, but when I'm doing my Java work, I want to have a different set of settings. When I'm in here in the classroom and I'm using an Eclipse, I want to have a different set of settings so that the font is readable in the back row in the text editors. Okay? So a workspace is just a way to encapsulate a set of settings. Now, I store mine under a directory. My C apps directory is just the name that I've used for the last 15 years for my directory structure. That's a directory that my backup routine will back things up. So anything under apps is going to be backed up every night, and I know my workspace will be backed up that way. By default, it's going to go under your user directory.
Is there a concern about spaces in the file path?
Yeah, don't use spaces in the file paths. Yeah, Windows and Mac all allow it, and even Linux and Unix systems allow spaces in the path names. When we're programming, just don't go there.
Have another thing that you break to worry about.
Right. So Exactly. So I'm going to create a new workspace here. I'm just going to call it Workspace Demo 2, and it'll create a folder underneath that Workspaces directory for me. I can say use this as the default, and then we'll bypass this dialog every time we start up, and it'll always go to that workspace. I leave it unchecked because I'm always going to pick which one am I going to use. Am I doing my Android development? Am I doing Java work? Or am I doing PHP stuff for the websites? When you start up Eclipse for the first time with a new workspace, it's going to have a unique view that you'll see only really for the first time with a welcome message on there. You'll get this welcome tab, and it's got some links into some information. Go over the features. It has some sample code. It's got tutorials built in, and just information about what's new in there as well. I'm going to go ahead and close this, and we're going to be presented with our basic Eclipse environment. Now, Eclipse has the concept of perspectives. I'm going to be writing code, so when I'm writing code, I want to have the screen set up in a certain way to maximize my productivity for the purpose of writing code. When I'm debugging code and stepping through things trying to figure out why does this variable have this strange value, I want to use a debugging perspective so that I rearrange the screen and I have different widgets on screen for the benefit of actually stepping through code and doing the debugging parts of this. And these are the perspectives. So right now, I have the Java EE perspective open, and I can go to my debugging one by clicking on this icon to open up another perspective, and I can go and grab the debug one. And now you'll see there's a lot of different perspectives available. I have PHP plugins installed in mine, so I've got a PHP perspective for doing PHP work. If I'm using source code repository, I've got a team synchronization for being able to synchronize with the repository. We'll cover a couple of these different perspectives. For the most part, we're going to live in the Java EE and the debug perspectives. So in this layout of things, I'm going to see my running processes up here. My code will be displayed here with the breakpoint set and a highlighted line of where I'm stepping through. I can have my variables display up here and then actual outputs down below. Whereas in the EE view, my text editors are going to go here, my file lists will go here, and the internal outline of my objects showing my methods and my fields will be over on the left side. Now, Eclipse is a project-based editor. You can't do anything without actually creating a project first. What was your name again? Ellery noticed this. He had a .java file that he wanted Eclipse to compile just by itself on its own. You can't do it. You have to create a project with Eclipse and then start working within the project. So to create a project, go File, New, and we're going to create a Java project. There are lots of different kinds of projects available in the Enterprise Edition of Eclipse. Enterprise Edition deals with things like web applications, server-side applications, and there are lots of different kinds of projects you can create. We're going to create a plain old Java project, so we're going to go to Other and select Java Project. Now, when I'm done tonight, I'm going to take my Java project that I've created here in class, zip it up and post it to the lecture notes section of the website. You can import projects by going File, Import, and then selecting Import Existing Projects into Workspace. So if you want to use the code that I had demonstrated tonight, you'll import it in this manner. You will have to do this for the midterm because I will hand you a starter project that you will import into your environments. So, creating a basic Java project. We got to give it a name. We got to tell it where to live. So, I almost never use the default location because that's inside of the workspace. I like to separate my projects from my settings. That way, if the settings get messed up, my projects don't get messed up. So I won't use the default location. I have a Java projects directory on my computer. Navigate through to it. And inside my in class, I'm going to create a new folder called Lesson 2. That is going to be where this project lives. And by default, when I name that folder, Eclipse picked that up and named my project by that folder name as well. So for convenience, pick the location first and then let Eclipse go and fill in that project name for you. I'm not going to make any changes to the rest of these settings. It's the first one here is the Java runtime environment. When the program actually runs, you can choose which version of Java that you can use to run with it. I've got Java 1.7 installed on here. I can install Java 1.2, 1.3, 1.4, and 5, 6, all the way on here, and I can pick which environment that I actually want to use to execute my program with. I'm just going to default at this point. My project layout, the creation of the folders as part of this project, I'm going to use the default values for that. And I'm not going to do anything with working sets. That has to do with being able to search subsets of code within your environment. I'm not going to make any changes on these tabs. I'm going to just leave everything alone. But I want to point out that there's going to be a directory called src created, and that's where I'm going to put all my source code, my .java files. My output folder is going to be the bin directory. So when Eclipse compiles, all the Java code is going to put all the .class files into the bin directory underneath my project. Now the rest of those tabs are for references for library kinds of purposes, when I need to import other code from other libraries. I can reference other projects within my environment. So if I've got a library project and an application project, I'm going to reference the library from the application on the projects tab. If I want to download some jar file from the internet to use somebody's library, I'm going to use the libraries tab to add that in as well.
So I'm assuming the import function for Eclipse allows you to keep all those file hierarchies. I mean, you could theoretically just go in and slap files into the workspace and keep that established, right? That's
right, but it's not efficient. If I've got 10 projects, but I use that same jar file in 10 different places, I don't have to have 10 copies of the jar file. I can put the jar file in one central location and use this library reference to have all 10 projects point to one file on disk.
So it's not that it'll keep you from doing it, it's just efficient.
Yeah, right. It's just for more efficiencies. You can have multiple file folders of source code. And we actually do that for testing purposes a lot of time. We have our code that goes into the production application, but then we also write code to do testing, to make sure our application is working correctly. And we don't like to put that code into the same directory structure, so often we'll add a test directory here. So we have two folders, hierarchies of code that's actually going to be used and compiled with the project. But then when I compile my production version, I ignore the test folder as a source. We'll actually have an example of writing some test code tonight. Now it's going to ask me, do I want to switch perspectives? It knows I'm creating a Java project and not a Java Enterprise Edition project, so it wants to switch to the Java perspective, which is pretty much the same as the Java Enterprise Edition perspective. Either one of these is pretty much exactly the same. The one difference that I'm seeing here is that the tabs for outline and task, you can switch back and forth. On the Enterprise Edition and the Java perspective here, it's actually set up as different panes. You can combine these by just dragging and putting it, and now it's exactly the same as the Enterprise Edition one.
If we happen to have put the classic Eclipse on our computer, is that going to be an issue, or should that change?
So my recommendation is always just to take the Enterprise Edition one because it's not that much larger. It's only another 100 megs of download. You probably won't run into a problem in this class. I don't think we actually have any dependencies in the Enterprise Edition for the Android development. But if you take the web application development class in the spring, you're going to have to reinstall Eclipse. So in order to get to all the web app tools. You can get all the same plugins through the add install new software facility. If you go help, there's a drop down here, install new software. If you go through that, you'll be able to add all the same plugins that we've got in the Enterprise Edition. It's not going to be a big deal. If you install something, a plugin that requires another component, it will tell you that there's a dependency there and you'll have to download and install that as well. I don't see it being a problem. I just recommend always getting the Enterprise Edition so you have everything already. Last thing you want to do is be sitting on the bus trying to write code and you don't have an internet connection, you can't get what you need. So, they're starting to, not all of them at the moment. So in this display, I've got a package explorer. This is not actually exactly representing the file system. There is another view that I can add to this perspective. I show view navigator. This is an actual physical location view of the disk. So here's that folder for the lesson. Here's the bin directory we created. There's the source directory we created. And I've got a .class path and a .project file that is part of the configuration files for this project. Depending on what you're doing will depend on whether or not you want to use the navigator view or the package explorer view. Most of the time in this class, I'm going to be using the package explorer view. In that view, we can see our source code. The bin directory is hidden away from us because we really don't touch it. We don't manipulate it when we're editing. But I have a logical reference here to the system library. So here is all the default libraries that are being included in this project just by the fact that I'm going to run things. It's a lot of the tools that just make your code runnable. So let's actually write a little bit of code here. I've got my project created. Now I need to start creating .java files to actually write some code in. So I want my .java files to be created inside the source directory. So I'll right-click on source, select new, and I'm going to create a new class. So the wizards here will help you get through building some basic classes. I'm ignoring package for now, but it's a warning. You're supposed to use packages. We'll talk about that in a couple of weeks. I'm just going to create a new Hello World program. There's a lot of choices on here. By default, it says it's going to be public. I'm going to keep that. My super class, the parent class, is always going to be the java.lang.object class unless you specify otherwise. When we look at our .java code, we won't see this in it, but it's being implied. If I want to extend, say, the shape class, I want to create a circle class here, I would specify my shape class in here as the parent. Would I like to create a public static void main for this class? Yes, please, because that saves me a bunch of typing. Constructors from superclasses, we don't need to worry about it for this example, but in the case of the shape and creating a new circle class, I might need to duplicate the constructors that are defined in the shape definition and duplicate those constructors in the circle definition for compatibility purposes, so that option is there. And I always want to generate comments. I sure did. I told you last week, I'll misspell my own name when I'm typing. So, Eclipse for us has already built part of what we want to do. I only have one line of code now to fill in here. Now, looking at this code, one of the first things I see when I'm looking at this editor is that I can't tell you to look at line 10 here. I really find it easy to communicate about code by saying, look at line 10 in this file. So to turn on the settings to put line numbers in here, I can go into my preferences. So I'm going to walk through some of the preferences, and I didn't print out a copy of my recommended settings to actually walk through them. In the lecture notes section, I have a document posted in there for settings that I recommend you do to make life easy in Eclipse. So I'll go Window Preferences. I get this wonderful dialog that pops up that's got lots and lots and lots and lots of options in here. We're not going to touch all of them. Under General, Editors, and let's see, Text Editors, I want to show line numbers. I like seeing my print margin because I'm so used to, from way back when, printed page being 80 characters wide, and I don't like things running off the side that much. So I'm going to show my print margin so I can see where it's at. I use spaces. I don't use tabs in my source code. Once upon a time, and this comes down to where you work and the place you work having a standard for how you write code. The standard for your shop is either going to be you use tab characters or you indent using spaces. Okay, I worked at a place that we use spaces, not tabs. And the editor tools that we were using at the time didn't have the ability to insert X number of spaces when you hit the tab key. So one of the things we had to do is, all right, everybody, you got to hit the space bar 4 times in order to actually indent things. I had somebody I was working with, and he just kept using the tab key all the time. I took a pair of pliers to his keyboard, and I removed his tab key from his keyboard. And he finally got the point, okay, we got to do, spaces instead of tabs. One of the things about Eclipse that I really like is it lets you be a lazy programmer like my buddy was. You can still use the tab key, but when you hit the tab key, it's going to insert spaces for you instead of a tab character. Let's see, what else do I want to change in here? Spelling. I have a dictionary on my system. I used to play down with Words with Friends. Everybody familiar with the application? Okay. In their documentation, I found their word list. They referenced the word list somewhere out on the internet. It was an open source thing. So I downloaded that word list, and that's my dictionary now that I've got installed on my machine. You can set it up so that the comments and your variable names and everything will be spell checked in Eclipse for you. Okay, so that's useful. I won't set that up right now because there's other things that I want to do. In the Java editor, I'm going to come back to this. And again, all of the settings that I would like to see that you'll see next week when I'm using Eclipse, all the magical things that happen are documented in that document that I've got on the lecture notes. So let's finish this one off, then we'll take a break. So I'm going to get rid of that to-do that's there. I'm going to type sys out control space. Oh, that didn't work. Ah. All right. Somewhere that was control space is what it was supposed to be. I got to look that one up. Maybe I don't have it activated at the moment. But there is a way to type sys out. I thought it was control space, and it replaced it with system.out.println for you. In actual real code, we don't usually use systemout.println. We use things like loggers. If we want to output something that's important, we're writing it to a log file on our servers to review at a later time. So we're not generally using system.out.println. Hit save. Now, I think this is a bug. There's 2 run menus up here. I think there's a bug in this version of Eclipse. You'll notice there's no run here on that one. And over here, there's where we find our run and debug. So I'm going to use the debug. Now, on this Eclipse being run for the first time in this environment, now it raises the firewall stuff. tell it to allow it. Down below, I have my console tab, and we can see here's my output, my hello world in black. System.out generates black text here. System.error, any error messages will show up in red down there.
So the one thing, I had that when I first installed it. My thing just broke. I tried to open it, I restarted, now I have one.
It might be the perspective that I'm using. I don't know. I noticed it a week or so ago, and I'm not familiar with, I haven't done any research to figure out why two runs are showing up.
You want to pass parameters to between how do you do that?
I've got an example coming up here. Okay. So running that, again, we was having some errors in here. So if I was to try and concatenate something on the end here, Eclipse isn't even going to let us start running the program. It's going to show us a little light bulb with the red X over there. It's going to underline the problem. And in this elevator bar side over here, it will show me a little red block there in case I was not actually seeing that piece of code. My code is so long that it scrolled off. Over on the side, I can actually just click on that red box. So if this was way below, I can click on that red box and have Eclipse take me straight to the error point. I can declare my string P. I've got it declared. What's the error? Null reference. That's a runtime thing.
How do you save it?
It's safe now. If I hover over it, what I'm getting here is, before we saw uninitialized class level variables, this is an uninitialized variable, local variable inside the method. So they're handled differently. The uninitialized class level variables are going to be initialized as zeros, but you're not allowed to have an uninitialized local variable. So that's an error in Java. So if I took that and I moved it to the class level, it should get rid of the error. Saved. Oh, now I'm getting to static problems. Okay. Now there's no errors, no warnings. I made the variable static so I can access the variable without actually having to instantiate the object. I should. Now I'm just going to push the debug button up there. I'm not getting a null reference here, a null pointer exception. I'm actually getting null. This object reference, when it did the string concatenation, right, it said, oh, the value is null. I'm going to show you the value null instead of throwing a null pointer exception. But if I said p dot, that's a string, character at position 1, now I should be seeing a null pointer exception. So in Eclipse, when an error occurs, it tells me it wants to switch perspectives. Something bad happened. So by assumption, the Eclipse editor figures you want to debug the problem, figure out what went wrong. So it's asking you to switch to the debug perspective. Switches, here are my running processes. Here's my source code. My highlighted line 15 here is where we had the error occur at. Over here in the variables, I'm showing what my local variables are. And let's see, my outline of the class, and then my consoles down below. So when it's executing that line, I can step over it using that icon up there, F6 to step over. And when that happens, it starts going through this error handling routine. So it transferred control over to a different class, so that's a different file, and I get a new tab in this area. The source code's not loaded in the system, referenced in the system, so it can't tell me what's there. But over here, I'm seeing that there's a null pointer exception. It shows me in the thread class dispatch on exception that is where the code is processing at the moment. So I'll just let it continue to run, and in my console at the bottom, I get my red error message. It said that in that thread in main, when I'm running these programs, it's always the main thread that's handling our programs, that a null pointer exception was thrown at hello world main method. It shows me the source code file, helloworld.java on line 15. If I click on that, it takes me right to that location in the source code. So then I can start editing and doing something about fixing it. All right. It's 7:40. Let's go ahead and take 10 minutes. And I'll start going again at 7:50. And our next example will be those command line arguments into the Eclipse. Okay.
Is there any way that can do a kickstart to get the Java working?
Well, we've got a bunch of tutorials online. Getting things set up and running, there's also the videos from last year. So if by the end of tonight that you don't actually have it running at a command prompt, that Java C and the Java, I'll sit down with you and we'll actually go through and make sure everything is set up before you leave tonight. Okay? All right.
I was a little unclear on that. Is it that you want Hello World or do you want Hello Date for the home?
Hello World. Yes. Yeah, he's got it there. He's got his JDK there. So, yeah, because you're using Hello Date as a starting point, a piece of code, and then modifying.
I almost submitted Hello Date.
No, that's, yeah. I've had people do that before. No, I just want to see Hello World. The idea is get your environment up and running. Type it. You'll get muscle memory over time. So, all right. What was your name, man? Hunter. Okay. Trying to get people's names down. You don't have to. No. Yes. Right. Making sure that they show up. You have to use @C, but you don't have to actually get that linked. Okay. That's optional.
Project B, how would you think
the Java development kit.
can we do like a main class that calls an object for the payroll, like a payroll class with a main method? I'm not entirely sure which other thing.
You construct it however you please, so long as it runs and it satisfies the requirements of the assignment. Now, whether or not you use one source file or two source files, that's up to you. And a lot of times people will just have a simple program that has the main method in it as the driver to start things off kind of thing. But you could also merge that into a single as well. All right? And so we'll have a couple examples tonight about actually doing it either way kind of thing.
In that case, any stylistic references to two different files or a private object and a payroll.
Do two different files. Yeah. Until we get into access modifiers about private, public, protected kind of thing, two separate files. Yeah. Sorry. Yeah, I take care of role at the end of the class. Okay. Okay.
I'm in the workforce of this, but
Oh, okay. So we'll get that paperwork taken care of at the end of the night then. Okay. Cool.
There's the JDK.
You didn't see it. Okay, we'll get it added on there because when Ermin walked in, it made me realize he's not on the roster either. So oversight when I copied and pasted probably. Okay, we'll take care of it at the end of the class for attendance. I don't remember his name. Nazario. Okay.
You could set the workspace thing. I think I want to look around and figure out how to bring that back on. You know how you said the very
Oh, to re-enable the selector? Not off the top of my head. It's somewhere in that preferences dialog. Somewhere. I bet it's under general. Yeah. So. Strings are actually immutable in Java. So when you actually go to change it or do a substring, you're getting an entirely new string. So when we spend the lecture on strings, we're going to be talking about the efficiencies of that stuff. Because again, there is a number of special things about strings that are not even stored in the same location as regular objects. So yeah. All right, I'm going to take a pause here.
Easiest way to figure out if it's working is just create a new folder in there.
Fucking stack in file.
Control test, and then go in here, and then copy and paste a .java, like your hello world.java, just put it in here.
Rosario? Found it. General workspace prompt. Oh, no, wait a minute. That's reference projects. All right. No. Yeah.
Zero on the desktop.
Come on, forward space on start. There we go. Yeah, I did. We'll take care of late entries at the end of the class. So, there it is.
That I just made right there. Okay. So you're going to take your hello world.java. Okay, so you'll see it. Once it's in there.
Yeah. I used to. Right. So when they gave me the ability to start teaching web application development using Java, I handed PHP off to somebody else, and now they're doing it. So, right, there's a second one. So we actually combine Java programming with HTML and CSS, and we do Java web application development. JSPs, no, we won't focus on JavaScript because that's client-side. We do server-side programming in Java. So we do JSP, servlet, and we talk a little bit about different frameworks for web application development as well. Yeah. So it's like the PHP class. The first half of it, we cover the basics kind of thing. The second half of it, you work on a project. Okay. Yeah, because my office hours are from 5 to 6. So, yeah. Yeah, no problem. Yeah. All right. You don't want it to be putting the curly braces in for you? When you get to the end of the line, you just hit enter, and it'll put it there for you. Okay. Whenever we start lecture again, I'm going to get to that. Okay. I'm going to go into some setting things. We may not exactly find that one, but I'll give you the area to look at. Okay, grab a seat and we'll get going again. So one of the things about my Hello World program here is that I've got all that white space that was left here. And if I don't actually let the system indent things the way it is, things aren't indented nicely. What I'd really like to have happen here is when I hit save, I want Eclipse to format my code for me so it's pretty. So it follows all of the conventions that my department that I work with want. Convert all the accidental characters in there to spaces for me, indent things nicely. If I've rearranged code, I just want to hit save and have it automatically fix all the indentation for all blocks of code for me. So right now, I want to have the system fix this indentation, and I want to have it clean up this extra blank lines that are there. So I can go back into my preferences again. It should be. I never actually paused it. Yeah, there's no. It looks like it's recording. Yeah, the old interface was good because it actually showed that there was going. So. Okay, so under my Java node in preferences, I'm going to be looking at code style and editor for 2 places. It's going to look like I'm going to make some of these settings in three different places, but if you do it in all the places, it'll keep your code nice and neat. The first thing I want to do is set up my code formatter. By default, there's a number of code formatters already set up for you. The Eclipse built-in one. There is a Java conventions code style, and there's an older version of the Eclipse code style. Now, you can't edit these formatters. These 3 that are included, they're static. You can't change them. So in order to define your own formatter, you have to create a new one. So I'll say new. I want to base it on the default Eclipse built-in one. And then I can start going through and making some changes. And I get a new dialog box up. When the first things I want to change is my tab policy. Is from tabs only to spaces only. My indentation, I use 4 spaces for my tabs. You may choose to use 2 spaces for your tabs. Let's see. I'm winging it right now of all the settings that I was going to make. I think it was just that one.
Are you going to give us a formatting style that we have to use?
No, you don't have to use it, but you're going to want to do this so that your own code stays consistent. The one thing I want to turn off is disable the automatic formatting of JavaDoc comments, because one of the things I find is when you put actual HTML code in your JavaDocs, you have a tendency to want it formatted in a certain way, and having Eclipse formatted, that usually makes a mess of your HTML code. And so I find unselecting that is useful for the comment formatting.
One thing I noticed with the docs, you had an opening P tag and a closing P tag. Are we not doing closing tags?
That was a bad HTML example then. In good HTML, you should have the closing tag. Yeah. I'm not really certain. It depends what spec you're looking at. It depends what specification you're looking at. The newer versions, you should have closing tags. So I don't know how JavaDoc tool actually deals with that. And do enable the formatter on-off stuff so you can actually say, hey, don't format code that's in between these two annotations. That's kind of useful in that if you've got something set up just right for some reason, you can ensure that you won't be changing the code here. So we'll apply that, and that'll be the formatter settings. Then we're going to go do the same similar kind of thing for the cleanup settings. I'm going to create a new one. Now some of the settings here are similar and some of them are actually different. So one of the first things I want to do is tell my formatter I'm going to be formatting the source code. On each line I'm going to remove the trailing space. So if there's any blank spaces at the tail end of my lines, I'm going to truncate them. I always want it to correct the indentation, fix the indentation of blocks for me. I want it to organize imports, but one of the things that can happen with the organizing imports, sometimes you'll have imports drop out of the list because you're not using that class, but you hit save in between deleting one line and inserting another one, so it can get a little flaky whether or not you use organized imports or not. It does reassess what you need, yeah. And if Eclipse can figure out what import to add, it will do it for you without any prompting. I always use blocks in my if file, all my different control statements. So I can write an if block. I can say if, open parentheses, whatever condition, close parentheses, and then write my statement on the next line. And as soon as I hit save, it automatically puts the curly braces around that statement for me so that if I ever have to edit it and add a second statement to the condition that gets executed, the curly braces are already there, and I will know that I'm not accidentally adding it in the wrong place. A lot of places I have worked have had the rule, you will always put curly braces around all blocks. So I want to convert my for loops to the enhanced for loops automatically. That's nice for when you're working with old code, you're updating something, it updates from the old style to the new style for you. I always use the parentheses because I always think it's cleaner. I let Eclipse figure it out because Eclipse is figuring out how Java is going to interpret the expressions. Have it put the parentheses in there for you, and then maybe suddenly you'll realize why you got a bug in the conditions because it's not evaluating the thing the way you thought it was. We leave that alone. Keep the add missing annotations in place there. This is the one I don't like to have. I like to remove unused imports. Eclipse will give you a warning and say, hey, this import's not being used, and so you can remove it. But because of my experience with the Android environment, I like to turn this one off. There's some Android build tools where it does some pre-compilation generation, and some classes don't actually exist until that work is done. And then once it's done, then it exists, and then Eclipse will be happy that you have imports. Yeah, too many times, banging my head against the wall, going, I had that imported correctly. We'll talk about the R class when we get to Android.
Question about on the end of the if statement.
So long as you're consistent within your own code. All right? So, save actions. This is the trick to getting everything to play nice. Go to Save Actions under Editor, perform these selected actions on Save, format source code, all the lines in the file. I'm letting it organize the imports. And these additional actions, this looks a lot like the cleanup again. I'm removing trailing white space, correcting indentation, always using the blocks, using parentheses. See here, it's already unchecked, remove unused imports. And I think that was all I was changing. And again, all this again is documented in that file I put in the lecture notes. So I'll hit Apply, I'll hit OK. I'm just going to make a change in the file, so I've got an indicator up there that the file's dirty, and I'll hit Control-S to save, and it reformats everything for me. The indentation is done. It collapses all that extra blank white lines, and it cleans things up. Now I can be as sloppy as I'd like as I'm typing away, and every time I hit save, the editor will go and clean things up for me.
Kind of on topic here, can you set like these settings as a default for all like whenever you make a new workspace, how to use these?
You can copy your workspace from one directory structure to another if you want to do that. The formatters and the cleanup profiles can be exported, and then you can import them. So like what we do at work is we have one person set up the formatter profile, we save that off, we put it on the server, and all right, every time you set up a new environment, go and import that formatter. So you found in there, okay. So is that with the assist? So the question had been, all right, when you hit Enter, you've typed the open curly brace and you hit Enter, Eclipse automatically adds a closing curly brace for you. And he was asking, how do we turn that off? Right. Say again, I can't hear you. At the bottom, there we go. Automatically close, so you can have it automatically not put the double quotes for a string, the parentheses, or the braces. There you go. So if you don't like having it automatically complete things for you. On the content assist, that's one thing I remember that's in the document. Now there's auto suggestion of, hey, you typed an object reference, you typed a dot, and then what is the list of methods that I can call on it? This setting here says there's a 200 millisecond delay between when I type dot and when it pops up the suggestions. It's actually a little long, so I like to put it at 50 milliseconds and it pops up really fast.
These settings are saved to this workspace, right?
Right.
When you open Eclipse, this workspace, you're going to have to.
I'm not going to have to redo it, right. But if I create a new workspace, it's all back to defaults again. Even line numbers. Yep. But that's the idea of the workspace. It's the container for the settings. So you create a new workspace, you're resetting all the settings. So, but again, it's just a file, a directory structure, and you can copy it from one to another if you want to duplicate things. Because I'm using some unstable tools on my day job, it has a tendency to occasionally corrupt my settings. So I back up my workspace, and that happens, it gets corrupted, I just go and delete the workspace, and I restore the backup, and then I'm back working again. All right. I think that's enough on settings. Let's go ahead and start taking a look at some other examples. So for Project C, is going to walk you through writing code on reading command line parameters and doing some work with it. But the exercise part of that project is that assignment is broken down to an exercise for you to complete and then an actual project for you to do. It doesn't mention anything about Eclipse, how to get Eclipse to actually recognize command line parameters. So I wanted to go through an example with you on that tonight. Create a new class. Hello. And I want my main, I want my comments. I get my main method. So when I run my program, command line parameters are going to come into the string array on my main method, so I can do some work with them. In this case, I'm just going to echo out whatever comes back. This is an example for saying hello to a list of people. If in the case that I don't enter any command line parameters, I want an error message to go back to the user. So my array is args, and one of the properties of arrays is the length. So I can find out what the length is. Now as soon as I hit that dot, this popped up 50 milliseconds later, and it shows me all of my methods that are available and the fields that I can access. So I want to access that lengths field. So that'll tell me how many elements are in the array. And if it's equal to 0, then I want to have an error message presented.
Length isn't a method name?
It's a field. No, that's an array.
Oh, yeah.
That's an array, and it is typeless when you're looking at that part of it. You're looking at a property of the array, not of the elements of the array. So if we don't enter any names, we want an error message to come up, and I want to stop executing. So I'll return here. Now, in this simple program, we could choose to exit, which that means terminate the Java virtual machine. Only in the rarest circumstances should you ever call the exit method. It's actually on the system class, system.exit. That causes the Java virtual machine to shut down. In these little examples, it's not a big deal. But if you're running on a server and you hit an error condition and you called system.exit, you're shutting down the entire application server that you're running in. You don't want to call that method. In fact, our build system at work actually scans the source code and says, okay, if you found a system.exit, fail to compile, raise a red flag, and get somebody to fix this, because that can't go to production that way. So instead of calling system.exit, and I actually explicitly say this in your homework assignment this week, just return. Don't call system.exit. So in this case, in the error condition, we will return and exit the main method. And that'll hand control back over the Java virtual machine. Since it doesn't have any more work to do, it will automatically shut itself down. But again, in a server situation, you don't want to call exit. So I want to iterate over the array. So we'll use a traditional for loop here. One of the things I learned when I was first started with some scripting languages, instead of naming simple counter variables, like instead of just using I or J or K, double up the letters. it's easier to do a search and replace on them and actually locate those simple counter variables. Now you can see how as I type, everything's going off to the side. But when I hit save, I thought it was going to. It's probably I just don't have enough room here. I'm still inside my 80-character boundary. To make the editor take up all that in space, all I did was double-click on the tab at the top of the editors. To get back to that view, all I have to do is double-click again, and it goes back. Question?
So the array is sort of like an object?
It is a first-class object. It has methods and properties.
So when we make a new array, we don't have to say new array of this type.
We do use the new keyword when we create one from scratch. Now we're being handed one here in this method.
Oh, okay.
So that's it. The array is actually an input from the calling client. But yes, we do use the new keyword. That was actually in one of the slides when we create an array. So I'll iterate over it. I'm just using the II as my index. I'm going to output the index, spelling again. And again, accessing each one of the elements in the array is just like C and C++. We're using the square braces and the index variable there. So I'll jump back so I can see the console here. And we'll hit debug. And when I run it, it says hello to, and then I get my error message. Please enter some names. Well, I need to enter some names. But command line arguments is not part of any of the interface we've seen so far. We're not reading keyboard type in from standard in. We want to actually receive it as part of the arguments of the program. So to set the program arguments, we go to the run. Now that I've run it for the first time, I can actually get into the configurations for rerunning this again a second time. So I'm using debug, and it's the same for run. I want to stick with the debug concepts for what we're working on here. We go into debug configurations. Then we get this dialog, and on this main tab it says, okay, I'm in project 2. The class that I want to run that has the main method in it is my hello command line parameters. But then on the next tab is the arguments tab. And I've got two boxes here. I've got my program arguments and my virtual machine arguments. Virtual machine arguments are the arguments you provide to the Java application. When you type Java, you can say dash something. You can control memory allocation sometimes with it that way. That is the VM arguments. Again, if you want to use something like that, you need to go into the manual and figure out which virtual machine arguments you need to use. At this point for us, we don't need to change any of those. But the program arguments, that's what's being passed in to the main method in the array of strings. So I can say give that list of names. If I hit enter there, it's going to be a new line, and I don't want to do that. I want to keep everything on the same line. I'll push the debug button, let it run again, and now in my output down below in the console, I can see index 1 was Joe, index 2 was Bob, index 2 was Sue, 1 was Bob, 2 was Sue, 3 was Jane. So we can do that for reading the command line arguments. Now, one of your assignments was to do some math with command line arguments. Now, when you get the inputs into your programs, they're strings. And so you need to convert the string values to integer values in order to perform math on them. So let's take a look at a quick example of doing that conversion. So in this case, definition of this program is I'm going to take two numbers as input, and I'm going to provide the sum and the product of the two numbers. So if I don't get two numbers in, I want to get an error message. That is correct. If the length is not equal to 2, the input array is not equal to 2, then I'm going to issue an error message. Sure, I'll do it on air, just so we can see some red text. Now, something to keep in mind because you brought it up. System.out is one output stream. System.error is a second output stream. I have one console display. What can possibly happen with those two streams displaying in the one window is that the output gets intermingled. And so we can see that some error messages may be occurring in an erase condition being written to the window. So that might happen when you run your programs and when you're using both standard error and standard out. Yeah, it's not going to be that much on the midterm when it comes to file I/O because you've only had it for a week. But it'll be on the midterm. So I'm taking two numbers in. I want to convert the strings to integers. So I'll declare a local integer variable here, my int1. And to convert the string to an integer value, I'm going to use that integer wrapper object. And one of the methods on it is parse, and it takes a string as a parameter. So args sub 0 will be my first number. Arg sub 1 for the second one. Now char is a single character. These are strings. So you would actually have to substring out the individual characters in order to do that. No, because that would be a string. Args sub 0 is a string. Then take that, say char at position 0 kind of thing. You could do that. Whoops, missed a quote. Mm-hmm. How do you know to split up the args using spaces? Sorry, that's how we do command line. We always use spaces to separate arguments in command lines. That's a old command line convention. Sorry, I'm just so used to it being such an old thing. If you were to comma separate stuff, it would treat it all as one argument. At which point, then you would have to parse the things out based on that. So.
If you use backslash escape character and Eclipse, is that going to basically not tell it to have a white space, but actual character space? So if you say Joe Bob, will it treat if you say Joe backslash space Bob? Is that going to be treated as Joe?
Oh, you're trying to escape the space kind of thing? Yeah. That's not legal, actually. That's not a legal escape character. Yeah. But part of it's also operating system controlled, too. So whatever your operating system is using to separate the arguments, in Unix and DOS, everything I've seen to this point has been space separated. I'm sure somebody can write a command interpreter that uses something different could use commas if you created it that way. But it's the operating system is going to pass them as parameters in. So.
I know that when I'm trying to, in Linux, when I have a file name with spaces in it, in order to get those spaces without using quotes, you use the escape character space. And it treats it as an actual space character instead of the white space in the.
Okay, I've seen that. It would probably cause it to be treated as one argument.
Emphasis on problems.
You have to test it. Okay, so I've got this finished coding. So we'll parse these two into integers. Then we'll output the addition result and the multiplication result. So again, I'll run this for the first time, hit F11. Shh. I didn't enter any input numbers, so I'm getting my error message. I'll go to run configuration. I'll throw two numbers in there. We'll just use 1 and 2. Run it again. Result of addition. There we go. 1, 2. Concatenation occurred. So I'm going to solve this. What's actually happening here is that the plus is the only operator in Java that is overloaded. One of the features of C and C++ is operator overloading. We don't have that in Java. As a user, as a developer, you can't overload an operator. But built in, because they recognize that everybody is used to using a plus sign to concatenate strings together, the plus is overloaded to do both addition and string concatenation. So what's happening here on line 23 is that Java receives, okay, I've got a string, plus sign, I'm doing string concatenation. Concatenates this int, it converts the int to a string representation of the int value, concatenates that, converts that integer value to the string representation of its value, concatenates that together. So we got the result of addition being 12. Putting in parentheses is one solution we can do. So that's one of my solutions, is saying, okay, before I do this concatenation, do this operation first. And so Eclipse not Eclipse, but Java looks at that and says, hey, I've got two integers, I got a plus sign in the middle, I'm doing addition. The third solution was to take that out of the print line statement and create a new integer variable and then output that in the statement. But the thing you're going to need for your homework assignment is that guy right there, doing the integer parsing.
If we gave it A, B, this parsing is going to go in there saying you can't do this.
Go it over to ASCII or something.
I got a lot of red. Number format exception. That's not a number. I tried to convert it and I couldn't do it. It's nicely telling me, hey, I was actually trying to convert the letter A as a string. And it gives you a stack trace. This is referred to as a stack trace. It's the call stack of all the methods that it went through. From our main method, it called parse int, and then it called another parse int method, and then it called, then it created the exception. So we had to see what it was doing when that error actually occurred. You've got to look through the stack trace and find where's my code, where's my line of code that I can control. Don't worry about dealing with exceptions yet. We'll be covering them in upcoming lectures. But because you don't actually have to write anything in your code, this is referred to as a runtime exception. It only occurs when the application runs. There are other exceptions that are identified in advance that you actually have to write code to deal with in your code. Those are called checked exceptions because the compiler checks for those things that could possibly occur. And we're going to learn how to deal with those in a couple of weeks.
After we compiled, we're not given like a standalone binary, and we're required to have the Java virtual machine. Like we have to call the Java virtual machine in order to run a Java binary. Is that how that works?
Right. After you compile, then you run the Java virtual machine, passing the argument of the class that you want to run as the main method. And Eclipse is handling that stuff for you internally here.
Right. So then, if we're doing this just in pure command line, after we compile it, it would look like Java, the name of our program, Joe, Bob.
Yes.
Okay.
Now, my .class file is inside the bin directory. So I have to tell it to go find the classes inside the bin directory. So I -cp./bin to say current directory, go to the bin directory. There we go. That's telling it that the code that I'm running is not in my current directory, but it tells it what directory to go look for. CP is short for class path. So it puts the contents of the bin directory on the class path as a command, using the command line parameter. Okay. Okay. That's the name of the class that contains the main method that you're running. But this particular one, I've got multiple classes here with multiple main methods, in it, one in each one of them. Okay.
And you can only do that because Java or Eclipse already made you the code.
It built it for me, right? So if I looked in the bin directory, into directory listing typo, there we go. There is my 3 different .class files I've created so far. So now I want to give an example for doing testing. So I'm going to create a calculator class that does some calculations. Comments, I'm going to put a main method in here. And I'm going to define my own method up here. For the most part, at this point, always declare everything public. And then when we talk about the access modifiers later, we'll talk about what the difference is between public, private, and protected. I'm going to create a method that returns an integer. It's going to take 2 integers as inputs. Term 1, term 2, and we're going to return the sum of them. Now, I'm going to keep this short. I have my example is actually much longer here. I do error checking and everything. I don't want that line. RETURN, there we go. Term 1 plus term 2. Okay, so simple little utility function to add 2 numbers together returns them. I need to make sure this works correctly, that it actually provides the real results that I'm expecting to get out of it. So I'm going to use, well, this is a testing strategy, I'm going to use the main method on this class as a test harness. I'm going to write a bunch of tests in here and say, okay, I'm going to call the add method with some parameters and verify I'm getting out of it what I expect to get out of it. This is one strategy for doing some simple testing. And then after we do this, we're going to show a different way of doing it. So I'm going to test and get a result. Up. I want to call it. In order to call it, I need to instantiate a new object. Call it calc, new calculator. Did I spell it correctly? Eclipse will tell me. I've got, okay. So when I've got red underlines, Eclipse can suggest solutions for me. So when I hover the cursor over it, it says, you know, I can create a new class by that name if I didn't make, if it, in the case I was not actually making a typo, or change to calculator because it's close to what I've actually typed. All right, so let's see. We're going to add 1 and 2 here. And then I'll do a system.out. I could do an if statement to test if it's equal. And I can run this program this way to make sure that, okay, when I add 1 plus 2, I'm getting 3 like I expect. Okay. Try this again with some different arguments on it. Let's see, doing -1, and, oops, that wasn't negative. -1, -2. Since result has already been declared in this block, I need to remove the int part of this. Now I'm just reusing the variable. And F11, I'm getting a -3 when those two are added together. So you can do simple testing in the main method, but then you end up doing a lot of these copy and pastes. You're adding if statements in there to check, make sure that you got back what you expected. But one of the problems of this is I've taken my production code that has my add method in it, and I've mixed in test code. And so when I send this to production, there's going to be this main method that can be possibly called in the client's production environment. And having your test code in that production environment is generally not considered a good thing, especially because it's not going to be listed as one of the things you could possibly do with the software. And when the client is looking at the documentation, suddenly they realize, hey, it does something that you didn't have in the documentation, and as they start asking questions, it's like, what else does it do that it doesn't say in the documentation? So one of the things you want to do is separate your test code from the actual production code. So I'm going to create a new class that's going to run as a set of tests that'll test this class. So I'll go new, and I want to create a JUnit test case. JUnit is a testing framework that is part of the built-in Eclipse tools. With Classic, you might not have the JUnit stuff in there. I'll select this to go into the wizard. It looks very much like creating a new class because that's all I'm doing. Is I'm creating a class that's designated as a testing class. And I'm going to tell it, okay, give me a setup and teardown. We'll talk about that in a minute. And the class under test is calculator. I'm going to hit browse and select it from here just to be sure it gets it right. what methods on calculator am I actually going to run tests on? Well, I'm only going to test the add method on here. Now it shows me my methods that I defined as well as all the methods that were inherited from the java.lang.object. Okay, and this is the first time that I'm adding a test case. I want to add my JUnit 4 library to the build path for my project. It won't actually run unless I do this. So now I've got some base code set up ready to start creating a test. You'll see an import up at the top up there. There's actually multiple imports. We're importing the assert bunch of classes. You'll notice there's an asterisk on there by the wizard. It'll get sorted out by Eclipse. And then I'm importing a couple of classes in the JUnit package. And here's one of our first exposures to annotations. These are additional things we can write into the code to give hints to the Java compiler in the runtime of how is this going to be used. Now the JUnit package is defining these three annotations, the before, after, and test. It's this test annotation that says, hey, this is a method that gets run that tests the other class. Before and after are used for utility things. So if, say I need to set something up before I run each test, that common setup will be done in the setup, and if I have to clean something up, perhaps deleting records out of a database that were created by running these tests, I would do that cleanup in the teardown. So what I'll do is I'll use the setup to create a calculator object. I'll define the calculator object at the class level. No, because it's in the same package. It's in the same default unnamed package at the moment. If it was in a different package, they had different namespaces, then I would have to do the import. I like ergonomic keyboards. And I've never been thrilled with these chiclet keyboards that I've got on this one. Yeah, it's very similar to the Mac kind of keyboard there. I'm used to bigger, thicker keys. So, if I add 0 and 0 together, I want the test to assert that I get a response that I'm expecting. I expect to get a 0 out of it. So I'm going to tell this test that I'm going to assert that these two arguments that I'm passing in is equal. And I should be getting a 0 and calc.add, pass in zeros here. So this method hasn't been imported yet. It's part of the JUnit. And I'm going to add a static import of assert equals. So if anything besides 0 comes out of this add method call, then this part of the JUnit frameworks will generate an error and say, hey, this failed. You didn't get the expected result. Now I can run this by right-clicking on the calculator test, and I find it easiest to go down to Run As and then select JUnit Test, because we're not running a Java program, we're running tests as part of the testing frameworks. So it runs, and my JUnit results is the title on this tab. I should see green on all my tests. If it's green, that means all my tests passed. If I get red, it means at least one of the tests in my test class have failed. So let me create a test that will cause a failure here.
So you made a different test for
each condition. So I'm creating I'm making two different calls to the method that I'm trying to test, and I'm varying the inputs. So I want to use different methods. So they represent different test cases. So this is very simple. You might have test cases that are more complex, different paths that a user walks through an application kind of thing. But we want to separate them out into individual components, and that way we are doing very narrow testing. I could put assert equals, I could put both of these into one method, but if this one fails, the second one won't execute. In the case of having them separate methods, both of them will execute, everything will execute, even if there are failures. So I'll know on one run of these tests how many tests failed and how many tests passed. So this little button here lets me rerun all the tests, and it should execute all the new ones. Now I get a message coming back saying test add 2 failed. And down here there's a failure trace. And the way this is laid out is kind of lousy. I'm going to move that tab down here for a little more room. So it's rearranged itself a little bit. But I can see the assertion message came back. It says expected 0, but was 2. So it tells me what was expected and what actually came out of it. Using unit tests like this, or using JUnit like this, is a testing strategy called unit testing. The idea is we test at the smallest possible component. So for each method in my calculator that does work, I want to test that method to make sure it by itself works all right. Unit testing is something you should be aware of. When you get into an environment that you're writing production code, everybody wants to know is it working correctly? Small little testing like this is going to help you out a lot in order to make sure your individual components work well. After you take all your individual components and test them, you're often going to want to test them in combination with other components of your system. That's referred to as integration testing, and there are different frameworks within the Java environments, the Java ecosystem, that allows you to do integration testing so that you can set up multiple things, call multiple things. If you've got servers that you've got to coordinate in order to actually test, did this test scenario actually succeed? Integration testing is a little more complex. It's very easy for us to do the unit testing right now with Eclipse, with what we have. It's not required for this class, but I recommend that whenever you write a method that has to do some calculations, hint payroll in Project B, you want to make sure that the algorithm you coded works correctly. And using these unit tests is going to be a way to do that. So on Project B, one of the things that you should at minimum do is sit down with a pencil and a calculator and go through that table of numbers and make sure you know what the output should be before you write anything in your Java environment. Okay? If you do that, then you'll see, hey, I made a mistake on how to calculate over time. Okay? Could you use it in your class? Yeah, you could, but it would be bad practice because that's testing and that's not production kind of stuff. There is an assert keyword in Java, and I'm not really understanding what the hang-up is, but most shops don't want you to use the assert keyword. It was new in Java 5, and I know that was part of it. But most of the time, with the places that I've worked, on the list of things what to do and what not to do is do not use the assert keyword. So, but integrating testing frameworks into production code would be considered bad practice. Don't rely on commenting out. I just came across a single line of code. It's something that I did 6 months ago that was supposed to be pulled out before anything went to production, and I just found it last week in the live code now. And it's like, don't rely on something getting commented out later, is what I'm trying to say. So, fortunately for me, it was a declaration that was supposed to be removed. It didn't actually mess with anything, but it doesn't belong. So that's the problem of putting things in temporarily, is often they forget to be pulled back out. So there's no macros in Java. So the next thing that I want to build is a simple address book service. We're going to use 3 different components. We're going to build a contact object to represent an entry in the address book. And then I'm going to build an address book service that actually contains and manages all the contacts. Then I'll build an address book client that uses those contacts. We've got about 15 minutes left, so I don't think we're going to probably finish this, but I got to show you this one thing first as part of it. So we'll start with the contact object for defining what we refer to as a value object. It represents an entry in a table. It stores data. Its sole purpose is to hold on to data about a contact in the address book. So we refer to that as a value object because it just holds values. I do not want a main method. This is not going to be something that gets executed. My address book client will be what has the main method that actually gets executed. So I've got a contact now. Contacts have first names. They have last names. They have phone numbers.
First name, comma, last name, comma, phone, comma, this one. Guess not.
Like that? Okay, we can do it. It's generally not considered the best practices because when you do declarations, things that start falling off the end of the line, then people start forgetting that they're all the same thing. Just as good practice, it's generally considered best to put them all on separate lines by themselves. Now, one of the things that we talk about in object-oriented programming is encapsulation. When I define fields on my Java objects, I rarely ever want to have my client code access those values directly. I normally want my clients to go through methods to get to those. Because perhaps when I set a value, I want to do some math and store that as part of one of the properties of this object. So I only want to access these values via methods. So these should be private to the class, not directly accessible. So I'll use that private keyword here in front of all these. And I need the access modifier right now in order for this example to work. Okay, so now these are all private, and I get a bunch of warnings now by Eclipse because the warning is saying, hey, you've got these definitions, but it's never being used anywhere. Because it's not being used anywhere, it's just taking up extra space. Why do you have that here? Well, in this most simple value object, I want to create getter and setter methods for each one of these fields so that I can set the data or read the data via the methods and maintain my object-oriented encapsulation. I can write a bunch of methods for each of these fields, make them public, set capital first name. Now, this naming convention, lowercase first, starting with the lowercase for first name. Now when I create a setter method, I stick the word set in front of it. I uppercase the F in first as that change in the naming. Let's see. Okay. Now, my parameter is first name. I have a class field whose first name. I need to assign this parameter that field on the class. Say it again. Self. That's it in other languages, but you got the right idea. This, exactly. So when I say this,
And because this isn't the, we don't have to say star this.
yeah, because the asterisk, isn't that pointer stuff? Oh, because this is a pointer in this. Okay. No. No, no pointers. Keyword this. So this is, to clarify the scope. So this is the parameter first name. And this dot first name refers to my class's first name field.
And do you change it as a parameter to say param, which is going to this in front of
Nope.
the first name?
It's just because the naming clash. Yep. But this is the normal pattern when we set up getters and setters, is to use the same name as the field inside the object, inside the class definition. Oh. No. Okay. Control space in the Eclipse editor will finish a variable name, an object reference name for you. But the CCC confer application that's doing the recording interferes with control space when it's running. So if I turned it off, it would work fine. So then now I have a getter to get the value of the first name field. Now you'll notice the error message went away from that line 10 because now I actually have a reference to that. It's being read somewhere. If it's just being set still, what's the big deal? It's not until you're actually reading it is it being considered being used somewhere. Now, this is the pattern, what I want to do for all of these fields. You saw how long it took me to type that, right? Eclipse recognizes that this is something you're going to do on a regular basis. So you don't have to type it. I'm just going to hit delete, get rid of these. If I right-click in the body of my editor, I can go Source, Generate Getters and Setters. Do it for all of them. There we go. Pages of code written for you all of a sudden. So building these value objects is something that you do so often, because one of the things you got to do when you analyze your projects is to figure out what is the data model, how is the data is going to be organized for all this. And so a good portion of your application are going to be data model objects, value objects, just like this. And it's going to save you a bunch of time by just typing in what are the fields that need to be in this value object and have Eclipse generate that code for you and set up all of the getters and setters for you.
What's the number shortcut again?
It is right-click, Source, Generate Getters and Setters. Okay? It'll help you on Project B, and it'll most definitely help you in the Your Faces assignment later on, because there's a bunch of objects you got to create for that. Now, you'll notice there's a bunch of other generates down here. There's some things that I don't want to talk about, delegates and hash codes and equals, but generate a toString. One of the things that Java does for you is that there is the toString method defined on the java.lang object. That means every single object that gets created in Java has the ability to have a nice textual representation that you can use in a print line statement, in a system.out.println. If you don't define one, you're going to get kind of this ugly looking thing. It's going to be like a 6-digit number in that sign and something else after it. But you can define your own toString method and say, hey, I'm going to output all of those fields that are defined on the class, and it will generate the toString for you. So now when you say system.out.println, whatever contact object reference you're pointing at, you'll get this. You'll see what the first name is. You'll see what the last name is, instead of having that unreadable gobbledygook. This annotation on line 81 is an override. It says override. That indicates that in the object hierarchy, the class hierarchy, somebody else defined a toString method, and now we're going to eclipse that with our own. So again, that was the java.lang, the object toString being eclipsed, and so we're using our own.
Line 81 is required, correct?
It's not required. It's a hint to both the developer and the compiler. Okay. So if you put in an override where it doesn't belong, like here, now I get an error message here saying, hey, there is no set postal code up in one of the parent classes. Something's wrong. And so you can use this as a way to prevent errors later on. Say somebody modified that parent class and took it out. Now it'll break your code because it's reliant on that. It'll compile just fine.
If you call that, would it call this version or would it call the parent class version?
The override annotation has no effect on this or the parent version being called. Okay, it's truly a compiler help, and when you're working, okay, it'll cause an error in this kind of situation, but it doesn't control the actual. It doesn't control the execution.
The first time I saw Java was in 2003, and it was like a crash and parent thing. When did they add this? This is new.
Java 5, Java version 5, yeah, 1.5 added this.
When you say it's help to the compiler, you need to touch it and test it.
It's giving it hints to, hey, you know, this method should exist somewhere in the hierarchy. So it's telling it, saying, hey, there's something there. And my example here was that it would cause a compiler error because it was missing. Well, if somebody edited the parent class and we no longer had a toString, then an error would occur. It's ensuring that the object hierarchy is maintained. It does, yeah, integrity check, good. Yeah. Okay. I don't have enough time to build out the service in the client part of that, but I'll go and post the code that for accessing, creating the bunch of contacts, putting them in an array, accessing it, and then outputting them, because that will be a little bit similar to some of the things you need to do for Project B. So, any last questions? We're up out of time. Yes.
With the main, that has to be in a class, right?
Yes. All methods have to be defined inside of a class.
Right.
Yeah.
And if all we're doing in our main is calling other methods,
Okay. Hold on a second. One last announcement. DreamSpark. I'm going to be submitting your email addresses tonight when I get home for your DreamSpark accounts with Microsoft. I had announced it last week, but this is your last chance to say, hey, the school has the wrong email address that I want my account information sent to. Whatever you have on file with school admissions and records at the moment is where your account information is going to get sent to. Okay? So that'll be happening tonight, and you should see your account information probably sometime next week. All right?
I was talking about an email notification where they post on the board.
Yeah. I don't know. You'll have to look. I'm not familiar enough with it to tell you how to turn it off. My first recommendation.
Digest takes all of the messages and you have
The other recommendation is to set up a filter on your email so to take everything that comes from the message lists and put it into a separate folder. Well, I want you to look at that stuff and read it. People have questions. Okay. No, I work via email, and so when things come in via email, then I look at it that way, kind of thing. So use your email program to filter it, or figure out the settings. I don't know what the settings are. So attendance, you are not on the list. Okay. Okay. You were here last week. Okay. We'll get that straightened out. And I need to earn. Okay.
What we don't want is to put the main method in a class called main.
You can do it. There's nothing wrong with that. You can name the class whatever you want.
Well, I mean, the class name has to be the file name.
Yes.
Okay. So unless we want our program to be named main.
Yeah. You can name it. You can do that.
Right.
There's nothing wrong.
Unless that's what we want, we can probably name it something specific to what program name.
Yeah. I mean, again, it gets back to names that represent what's going on. You know, command line parameters, hello world, calculator, kind of stuff. Yeah. But you can do it. It's allowed. So.
I don't even know what I'm looking
I
I want to ask, since I was introduced to this just recently in C++, when you write this, what is that?
It's referring to the current object, that the current instantiated object that we're working on.
So that is so back on your Eclipse, it was the class you're in right now.
Right. So it's referring, yeah. So it's referring to my current object will be on type contact.
So
in order to call set first name, I have to have an instantiated contact object. So I've got an instantiated object, and this is saying on that current object that I'm working on, access its field named first name. You can also
instantiate a contact object.
Right. Then you can call set first name. Yeah.
Saves you whatever name.
No, it's saying point back to my current instantiation. Yeah. Not the calling, but the one I'm currently in the context of.
Okay.
Okay?
Okay, got it.
All right. Attendance. Okay. What was the name again? Jim O'Hara. Okay. Here we go. Good. All right. And Robert Pierce. And I think. Oh, Eric. Okay. There we go. All right.
I just need signature there.
Okay. What's that? There it is. So will we have these like every other week kind of thing?
Yeah, I think this is the last one.
Okay. All right. Cool. See you next week.
So what do we call David?
Please. Yes. Colin. Okay.
Yeah, so I just
You want to add the class? Yeah. Okay. I need an add code for you then. We exchanged email, right?
That's right.
Okay.
Like I said, I've been teaching myself everything, so there's a few holes, but I think I'll be okay.
All right, let's see. Okay, 8257. What's your last name, Colin? K-R-A-U-T-H-A-M-E-R. 8257, yeah. COLIN? 2 L's. Okay. Alright, let's see. I need to get more information from you because I don't want you to miss out on DreamSpark stuff. Okay, I need real estate. Okay, will you kindly type your email address for me here? Okay. If there's typos, it's going to go somewhere. The email is going to go somewhere else. Okay, that's cool. That's all I need to submit the. All right, and once you get added in there, I'll get your last 4 year student ID for the address book for the grades page of the class website. So the grades are organized by the last 4 digits of your student ID number. Grades will always be posted immediately after I'm done grading the assignment. So assignment number 1 is due Thursday night, tomorrow night by midnight. Probably Sunday, I'll get everybody's stuff finished grading and I'll have all the grades posted. So if I ever deduct points off of your assignment, I will be replying to your email and saying why. Okay. So if you ever notice that there's deduction on the grades listing and I didn't give you a reason why, contact me and we'll get to the bottom of it. I may have made a typo and given you somebody else's grade, or email got lost kind of thing. But I always want you to know why points were lost kind of thing. All right? Cool. See you next week.
So,
Nick, right? Okay.
I was wondering, I signed up for this class because I took C++ in high school, just like computer science course.
Mm-hmm.
It was cool, but I just didn't see any benefit other than getting a computer science degree in college, and I didn't want to do that. So I didn't really get into C++. I know you can do a lot of things, basically, with it. But I did a lot of web scripting, and that's kind of the direction I've been in the last 10 years.
Okay.
Longer, actually. And I don't know that much about Java or C. And I was wondering, like, I can see like on a smartphone using Objective-C or Java as the building app or something. Like, what are the other things you can build with Java?
Web applications is one of the big things.
Like the .do, like right?
Right. Those indicate that a particular frameworks is being used actually.
Is it faster, like the database-wise?
It's just different. It's just different. The capabilities of the different platforms are part of the reasons why do you pick one technology over another. In my situation, we're at the bank. We could do Java or we could do Microsoft.NET kind of thing. And the choice of the bank is they feel more comfortable and secure using Java than they do .NET stuff because .NET is owned by a single company versus Java that's being maintained by a group of companies, even though Oracle really owns a lot of it at this point. But there's so much buy-in from other companies that, if Microsoft changed their mind about how things worked, the bank could be up. Yeah. They can. There's one company in control versus many people in control kind of thing. So the bank feels more comfortable about it. Some of the common things about the .NET and the Java Enterprise environment are the ability to cluster your environments together. So now you've done web scripting in the past. Now you've done PHP.
Yeah, that's all.
Okay.
I used to do ASP, but when I switched to .NET, I was like, screw that. I had $1,000
They learn more is that, they relearn things. So now, one of the things about Java versus PHP, you can build web applications in both of them.
Yeah.
Okay, but there's different different reasons why would I pick one over another.
Okay.
Okay, for self-hosting, it doesn't make a difference really. If I'm going to use Java, am I going to use PHP? I can get all the tools for free still. Okay. With Java though, I can pay somebody and get support for like WebLogic as an application server. Oracle owns it. I can pay Oracle for support. I'm having a problem. I'm stuck. I know it's in the application server. I can call Oracle up and I've got a support contract and I can get help for it.
Okay, that's
In PHP, you don't necessarily have as much of that. I know there are consultants out there, but there's not as big company kind of thing for support. And so again, in my situation with the bank, they're looking for big name consultancies that'll help out kind of thing, as opposed to Joe who's a PHP consultant kind of thing.
Yeah, definitely. Okay.
Then you start getting into things like clustering. Okay, for mobile banking, we have 2 data centers, and in each data center there's 8 servers, and those servers have to talk to each other.
Yeah, all the database servers. Yeah.
Well, we have individual databases on both sides, and the database is synchronized with each other also. Okay, that's a database thing. That's really not Java versus PHP.
Yeah.
Setting up a cluster in Java is one of the features of the Enterprise edition of Java.
By
Is
cluster, you mean
having
database?
well,
Like
if
tables?
no, I've got 8 physical machines.
Okay.
And I've got a client of someone doing their banking on machine A. Something happened, somebody yanked the power cord on machine A. It went away. What you want to do is actually have that person fail over to machine B and continue on like nothing ever happened.
Yeah, that'd be nice.
That's clustering and sharing of sessions across the system. It's a redundancy thing. Right. Now in PHP, you can do a similar kind of stuff, but it really doesn't have a lot of built-in tools to actually cross-communicate across the multiple instances of PHP. So that large installation versus a smaller installation is one of those choices that you make it with. So you see PHP more for smaller stuff and Java and .NET stuff environments for larger applications where redundancy is important. High availability is one of the terms that they make a point of. Yeah, it is a big deal, especially when it comes to financial stuff. Somebody's doing their banking, you're doing stock trades kind of stuff, and you don't want to get a 500 error message coming from the server that something went down kind of thing. You want to make sure that it goes through. And the catches with these enterprise environments is that you can be assured that by setting things up correctly, that if somebody starts a transaction, it will get finished, or the transaction will back out gracefully kind of thing. So. Yeah.
Well, I have another question. That's
Uh-huh.
excellent. That's a great description. I just had no clue going into this class. One more question.
No, I got a quick one between Java versus PHP.
Yeah.
Java and .NET pay better than PHP.
Yeah, because everybody does PHP.
To train somebody to do PHP, it's not that difficult to get into it kind of thing. It's a little more of a learning curve to do Java and get good at it kind of thing.
Yeah, it's cool. I like just seeing how the object-oriented programming works.
Mm-hmm.
But a quick question. Okay, so there's a Java. It's an Oracle database, and it's collecting weather data every 15 minutes.
Mm-hmm.
A bunch of weather stations that I've sold for. I work for vineyards.
Okay.
And
oh yeah, they care about the They care about the weather. Yeah.
Yeah, and so we're using this weather system called Adcon, and they've developed it all through with Java.
Mm-hmm.
And it's terrible software. The interface is all through Java, but it's just really bad.
Mm-hmm.
And so I've been able to get into their database. I forgot how I did it, but to do it with PHP. I extracted all the data and put it into MySQL. But it turns into 5 gigabyte tables. And is there a way to make these tables? I got like a database designer, so that's the question. I don't know. But my idea is you take a table for each weather station, or you could do variables with SQL. I don't know. I haven't figured that out.
Was it an Oracle database you pulled the data from?
Yeah.
Okay. So that becomes issues of scale. Now Oracle owns both the Oracle database and MySQL at this point. They bought the MySQL. Yeah.
Yeah, that's cool.
MySQL again is designed for smaller kinds of things, whereas Oracle and IBM's DB2 databases are really for the big data problems.
SQL, Microsoft SQL?
Microsoft SQL Server. I put that actually in between the tier of Oracle and MySQL. But I know Microsoft wants to be at that same level as they're trying to get there. But the Oracle system is designed for handling much more data than MySQL is. So that's
been changing data types, it still doesn't.
Yeah, and there's not a one-to-one mapping between the data types between Oracle and MySQL either. It's called one thing in Oracle, it's called another thing in MySQL. They're close, they're similar, but
we're all talking about the scaling.
Yeah, that one.
MySQL to Java and web database you can finally use.
Right.
Okay, that's cool.
So is this a piece of software your company owns that you guys have the rights to go in and pull that out? Okay.
I've told them about it. And I've developed things on the side, and they're like, "Go ahead, you can sell it," because they want more business. Because really, their business is hardware, but they do software stuff too. So
that's why the software is crappy, because they want to sell hardware.
They sell their software. It's getting better. It's just they don't want to do a major upgrade. But yeah, it's pretty cool. And so my company's going to pay me to do this, I want to do an Apple class in Cupertino about objects. It's like a week-long thing.
Okay.
So it's for the Coca or whatever it is.
Okay, the Apple programming environment. Yeah, I'm not a Mac person. I'm not an Apple person though. I've got one on my desk at work, and I was going, how do I do a screen capture? So taking screenshots.
I can't figure out what button it is on the keyboard yet. I just got.
It's different. Yeah. Now, the class you're taking is it web objects, maybe? About objects.
Yeah,
okay.
It looks like the same thing as this place called Pragmatic Studio. It's like $5,000 week-long class.
Yeah, that's what training costs. Yes.
Yeah, and I wanted to take this first because I had no clue about object-oriented programming. And so now that I read a little bit, but I don't know. It'll be interesting because
cool.
From going from field consultant, because I basically sell chemicals and fertilizers right now. That's like what I went to school for.
Yeah, I see the hat, the insecticide stuff.
It's fun.
You're selling the chemicals. What company brands?
For Ag Unlimited. So we're a retailer.
Oh, okay. So you're dealing with Monsanto, BASF, and all of that kind of thing.
Yeah, Mono Ag. Lots of chemical companies. Mayor. And their sales reps come to talk to us.
Okay.
I have a license from California saying I can recommend chemicals. So it's like in a gist, I'm like a plant doctor. It's pretty cool.
My father is an agronomist. He retired from working from BASF.
Oh, really?
So yeah, I've been out in the field doing the research testing with him. So
that's cool. Yeah, we have. That's fun. Yeah, so it's a good job. It's just I just got a phone call. I had a phone conversation a couple weeks ago saying that they wanted me to be their IT guy, maintaining all their servers and making software. So
cool.
That would be a better direction.
Yeah.
Right, income-wise.
Income-wise, definitely. Yeah.
I'm dreading sitting in an office, but like you said, you can do it at home. So.
Do it at home, and you figure out different ways to get your exercise. I rode my bicycle over here tonight. I'm riding it back home. It's 20 miles round trip for me, and it's part of my weekly workout. So.
Well, that's cool. I should have gotten into this a long time ago because I love this stuff.
You gotta find your way. And if it wasn't the right time back then, it wasn't the right time for you back then, kind of thing. We've been sitting here talking, and we've been recording.
Oh, nice.
I've done that